So as we continue through here, we said we need to find the height after 3 minutes. Well, we already have an expression for our volume. We know that it is, I guess I was working in red, so I'll continue. So volume equals 3 pi over 16 h cubed. All right. Well, after 3 minutes, that we know that if dV by dt is equal to half a cubic meter per minute, if we then multiply that by 3, so dV by dt times 3 will equal 3/2 of a cubic meter. All right. So now we know our new volume. So that means that 3/2 is equal to 3 pi over 16 h cubed. 3's will cancel for us. 16 will move on top when you do your cross multiply. So 16 over 2 is 8 divided by pi equals h cubed, which would mean that the height is the cube root of 8 over pi, and we're working in meters. There we go. So we do know the height after 3 minutes, and we can take that information and now we return to where we left. And this is not uncommon. This is what a lot of your questions are going to look like. You're going to jump out and you're going to do a lot of calculations off to the side to find that missing information. So now I'm back here. dV by dt is 1/2 9 pi over 16 multiplied by cube root 8 over pi squared. And you're just going to leave it like that. Obviously, you don't have a calculator. To check your answers, though, in the worksheets and the homework, obviously you have to punch that through. But that's where you'd leave it, and it's meters per minute. So therefore, the height is changing at 1/2 over the 9 pi over 16 cube root of 8 over pi squared meters per minute. All right. So that's it. So you move on to the next question from that point. So our next example. Water is flowing from a cylindrical tank at a rate of 2 cubic meters per minute. So cylindrical tank. So I'm just going to draw as best I can. And it's flowing from. So from would tell me that it's going out. With cylinders, we have radius, we have height. All right. So if it's flowing from, and we have 2 meters cubed per minute, that would tell me that this is a change in volume with respect to time. And because it's flowing out, it's going to be negative. Volume is changing and it's decreasing. So it's negative 2 meters cubed per minute. If the radius of the tank is 8, determine how fast the water is falling. So that water level, the water level's there and there. What are we really looking for? Well, we're looking at how fast is the height changing with respect to time. Now again, you'll note we don't have dr by dt, but I always talk about this for a second. You got to be careful, because what do you know about radius? As the height decreases, the radius stays the same. So in this case, radius is a constant. So you got to be careful with which shape that you are dealing with, because sometimes radius and height, sometimes they may turn out to be constants. So very, very important. So what is the volume of a cylinder? Volume of a cylinder is pi r squared h. So again, I'm going to do a bit of a pre-analysis here, so you may not want to copy this down. I'm going to end up, if I take a derivative, I'm going to get dv by dt. I'm going to get a dh by dt. Remember that pi and r squared, because r is in fact a radius or a constant, we're not going to have a dr by dt because it's not a variable, so we're not going to take the derivative. So I know what this is. I'm looking for this, so we're all set to go. So this turns out to be actually easier than the previous question. All right, so dv by dt is equal to, actually, before I do that, sorry, let's get rid of the r, so there's no confusion. Pi 8 squared h, so volume is 64 pi times h. That way there is no confusion. You won't make the mistake of taking the derivative of r. Now I'll take the derivative. dv by dt equals 64 pi. No more h, but remember there's still a dh by dt. We're looking for dh by dt, so I'm going to divide both sides by 64 pi. I have all the information, so I just need to plug it in. So negative 2 over 64 pi, and we can reduce that to negative 1 over 32 pi meters per minute. Does it make sense it's negative? Yes, the height of the cylinder, the height of the water is going down, so it's decreasing. So there is our final answer. So therefore, the height is decreasing at 1 over 32 pi, and we're working with meters per minute. And there we are. All right, as we move into the second part, normally I would do this over 2 full days. It would take 2 full periods, so it's a little bit different when you don't have the interaction, obviously. So I'm going to finish off these last 2 examples. So this time we have a ladder 6 meters long against a wall, and it begins to slide. So very, very important that you draw your diagram. Okay, so here's my wall and floor. Here's my ladder. Now the ladder is 6 meters long, so very, very important because that's a constant. That's not going to change. Your ladder, we're not looking at an extension ladder contracting, or I don't have to play the what if game for 15 minutes. Okay, so the ladder stays or remains 6 meters in length. Begins to slide. So what I always do is, we know this is the right angle. I'm going to call, for simplicity, I'm going to say that length there, or that distance is x, and I'm going to say that distance there is y. How fast is the top of the ladder falling when the bottom of the ladder has slid 4 meters at a speed of 1 meter per second? So there's a whole bunch of information there, so we got to go back and decode a little bit here. So how fast is the top of the ladder? So the top of the ladder is up here. So we are looking at dy by dt. We want to know how fast is it changing or decreasing when the bottom of the ladder has slid 4 meters. So we're looking at the ladder moving, or the bottom of the ladder moving 4 meters. And we know the speed of the bottom, so dx by dt is 1 meter per second. All right, so there's the information decoded. That's what we have. Now the question becomes, what relationship ties all of this together? So we need to tie all this information together. And this always shocks/frustrates students because the information that ties everything together is good old Pythagorean theorem. A squared plus b squared equals c squared. So we're going back and using a lot of grade 9 concepts. In the first couple of examples, we were doing volume of cone, volume of cylinder. Now we're back to Pythagorean theorem. And for our situation, x squared plus y squared is going to equal the hypotenuse squared. And actually, we can just write in the 6 squared, 36, because it's a constant, 6 squared. Now we're going to take the derivative. So it's just power rule. So taking the derivative of 2x, or x squared, you get 2x dx by dt plus 2y dy by dt, and it's equal to 0. Remember, 6 squared is a constant, so it ends up being 0. We're looking for dy by dt, so I'm going to isolate that. So I end up with 2y dy by dt equals negative 2x dx by dt. Now I see that the 2's will cancel. So dy by dt is equal to x dx by dt divided by y. So do I have all my information to do my substitution? I know what x is. I know dx by dt. I don't know my y value. So here's one of these moments in time where we jump out and we do a calculation. We know x squared plus y squared equals 36. That's from right here. So we want to find, or we know that x is going to be 4. So 4 squared plus y squared is equal to 36. Y squared equals, so 4 squared is 16, so you're going to end up with 20. Y equals the square root of 20 meters. That allows us to return back to our question and plug in all our information. So we're going to have 4 and 1 and square root of 20. And I noticed that I forgot to bring that negative down. So it should be negative x, negative 4. So we end up with negative 4 over root 20. And that is, using your units, y is measured in meters and time measured in seconds. So therefore, the height of the ladder is decreasing at 4 over root 20 meters a second. It's kind of funny because a lot of people, gut instinct here would be that if the bottom's going out at a meter per second, then the top should be dropping at a meter per second, and it's not in fact true. There isn't that linear relationship. On to our final example. So spotlight at the school dance is mounted 8 meters above the ground. A girl 1.5 meters tall moves away from the wall at a speed of 3/4 meter per second. So determine the rate and change the length of her shadow and the speed of the tip of her shadow. And I'm going to have to break this off because I don't want to rush through this one as well. And I'm going to just do the same thing. I'm just going to continue through. But at this point, you can start into your related rate homework questions that are listed here on the website, the first 2 homework sections. So we'll see you in the next video.